Ahoy Captain, and welcome to this episode of how to decarbonize your ship. Today we're going to look at a general cargo ship and we're going to add a battery pack to it to make it a battery hybrid. We're only going to do it while it's moored. Maybe later we're going to look at it for its full voyage, but that's for later concern. So in this case study that we're going to call the General Prius, we're going to see for this particular example, up to 30% or more CO2 reduction and fuel reduction while at berth. It can be a lot more, it can be a lot less, we'll show you, but this is roughly what we're going for. Basically depends a lot on your engine settings and load. Capex of roughly 150,000 for equipment only, lots of variation there as well, but we'll show you where the pain points are. The payback rate is about 4 years, depending on how you count it, but I'm gonna definitely recommend a lease or a rental in this case, and I'll show you why later. But basically the cost for leasing can actually be the same as the cost for fuel reduction. So in that way you don't really have a cash out, and that saves you a lot of trouble and might actually score you some points in Fuel EU, EU ETS, etc., which is also included. And then finally, for this General Prius case study, we've gotten help from one of our preferred partners, Royal Roos. Thank you very much, Royal Roos. A few disclaimers before we start, however. The tools that we use are of course only a model. We don't have your ship specifics, characteristics. We make a lot of assumptions, so we do a lot of case studies for you to get a look and feel on it. Use the tools themselves, abuse them in order to get your own models, estimates, and of course strategies for making better decisions in the long term. It's constantly evolving as well, especially in the end. I'm going to show you one feature that we're working on, but basically if you watch this movie you might have a different freemium or premium tool in front of you. Hopefully it evolves to the better. And then finally, it's made by humans. We make small errors, hopefully they remain small, but if you see anything that you think is incorrect, contact the help desk and we will make sure that it is fixed. And then finally, it's made with publicly available data. That means that sometimes we have to guess, but then again, you can use the tools for yourselves as well, and then you can fill in the gaps where we don't have that knowledge. So without further ado, let's dive into one of my favorite topics, which is battery hybridization for ships. But first, a little context. For those of you who don't need any context, skip ahead to the fun part. But I wanted to show you the ship that we're going to take as a base case, and also how the tool itself fits in the decarbonizer tool. That's our general tool. So first we're going to show you the ship that we mean. We have a general cargo, and then we go to general cargo ship. And if you go to ship properties, this is our reference ship with according ship properties that we take. So because we're looking at idle moored while at berth mostly, that's what we're gonna dimension the battery pack for. We're gonna have a special look at the Sisu engines, 116 kilowatts roughly, in order to make estimates while this vessel is moored. And you can already do that in the decarbonizer by making it a battery hybrid. But here, because the sailing profile is included, you get a very different case study. So right now we're just going to take the information here and we're going to put it into the battery hybrid single engine tool. So again, it's only while moored or at berth. If you do want to make like a full electric or battery hybrid, we'll do it later on, or contact the help desk if you want to do it faster. So here you see some more context and information, and here is the tool. This is the membership page. Some features here are the premium features. So if you're using the freemium, that might be the case why you cannot use it. So what do we have here? So this is basically a graphical overview of the process that we have. Here we see the generator is on, refilling the battery pack and also operating all the equipment. We already got the remark that of course if your drive shaft or propeller is vibrating that much, you have an issue. We know that, but this is simply to show you that something is running and keeps on running while you have the battery charging all the equipment. But this also means that you have some sort of diesel electric setup. I'll show you later the details how we incorporate that. But if you have like a fully direct drive or anything, then you might have to take into account some extra switchboard modifications. Anyway, maybe moving too much into detail, basically what we have is the battery pack powers the equipment, and when the battery pack is down or decharged or fully depleted, then the generator kicks on, recharges the battery, powers the equipment, and the whole cycle continues la-di-da. Basically we want to have one cycle while moored, so that you have your battery pack to be able to power the ship for one night or a period of 12 hours, so you can shut down the engine, have some fuel savings, maintenance savings, regulatory savings, etc. So the engine power that we saw, that is 160 kilowatts. The average engine load, so this is going to be a case study where we have a pretty low average engine load. I'm going to put it at, let's say, 18%, just to deviate a bit from the normal. And then you say that we have you see that we have an average power demand of about 21 kilowatts on average. I've seen a lot less. In reality, I've seen many ship owners who only have like, well, the engine barely scraping by at 10% or less. So I'd say 18-20% is usually our average power load of the engine while the ship itself is moored or at berth. But again, it really depends if you're unloading, loading, need extra equipment, just sitting there for the night. Lots of variables. I'm gonna stick with 8 running hours, and then we're gonna, there we go. This is already close to the case study that we want. So here we see cash flow, business case, and also payback rate, basically. And a few parameters there to customize, but what we're going to do first is have a look at the technical specs to make sure that everything that we have and want is included. And then I'm also going to scroll down a bit because I do love that animation, but the vibrating part that gets on my nerves as well. So here we have the power demand profile, and what you can see is that here's our average hybrid power demand. Here's the discharging of the battery, the generator kicks in, and once the battery pack is full, the generator kicks off again and the cycle continues. What you also see here is that we incorporate the fact that the battery pack needs to start at the same point, same state of charge, or end as at the same state of charge as where it ended. Otherwise we get free energy in a day. So we model everything in a day. And of course, if you after 8 hours start sailing again, you can recharge the battery pack while sailing. So you get a different comparison, which might even be more beneficial for you. But we're going to assume a full day in which you have 8 running hours of the battery. And then you can see if you shift the amount of running hours to the left or to the right, it's quite hefty calculation because we calculate everything by the minute in this particular example. You also see that you have more time with the battery and that the generator is shut down. It also greatly impacts the battery capacity. And here we see that most of the savings that we get also in OPEX will be due to reduced engine hours and costs, and of course reduced fuel consumption. I'll show you that in the, let's see, engine part. And then one very important aspect that we definitely cannot tell you much about in advance, but you have to look into, is the parasitic load and electric losses of the system. The parasitic load is basically the load that the engine needs in order to operate itself. It's like fuel pumps, fans, cooling, heating anywhere else. So that's basically the load of equipment that you need to keep the engine running. Especially at a very low power demand of your engine, this can be very high, up to 40% I've seen in cases. But you can simply remove it here, and what it means is that your average amount of energy will simply be increased. So I'm gonna stick to 15% because I know that's already a bit conservative. And the electric losses are the opposite. There are electric losses in the battery pack. You put energy in and it goes out. So roughly 5% in these cases is pretty conservative as well, but you can also increase that to 10%. And basically what it means is that you have to put more energy into the battery in order to get the amount of energy out that you need. So I'm gonna again get back to a 5%, but you immediately see that, okay, you need a bigger battery pack, but later on in terms of the grand scheme of things, these two do impact your average load. Parasitic load, I'd say more. but simply have a look and talk with your supplier about it as well. And also have a look at your average engine requirements. Talking about engine, this is one of the most important aspects. So this is your specific fuel curve. So here we have the engine power, average engine load that you require, the resulting average power demand, and the engine curve. You see that we have about 222 grams per kilowatt hour when it's at its optimum. But in our case, we're running at about 18%. And this is where you get the fuel reduction from. Instead of having the generator run continuously at a very low and very inefficient state, we're going to go to a very efficient state. We've now put it at 80%. General, as you can see here, 80%. In the premium model, you can also change around with that. But we can also change the SFC curve here to make it less efficient or more efficient. I'm going to go with slightly less efficient because I noticed these auxiliary generators of these sizes typically are at around 240 grams per kilowatt hour. And here's an important aspect, the engine maintenance cost. We've included it here again. We can exclude it because it's not really technical, it's cost, but it's extremely important in the business case, as you'll see later. And I think 10 is quite a lot for these amounts of engines, but well, it all depends. We've seen worse, we've seen a lot better, but keep that in mind. So making a good specific fuel curve is extremely important, and here we have the same graph again, but then specifically tailored to the battery itself, because basically the battery pack, the kilowatt hours, the cells is the most, let's just say, the biggest part generally of the entire equipment cost. All depends on your cell price, of course, and we've seen amazing drops in cell prices lately, so 500 euros per kilowatt. I'll get back to it later. But anyway, if you have a look at the state of charge here and you reduce it, then you basically say that you have the battery pack needs to be at a lower state of charge, so less charge, so you need to increase your battery capacity to still deliver the amount of energy that you need. I'd say 100% maximum limit to 20% is perfectly doable. Usually we stick to 95 just to err on the conservative side, but in this case we're going to go for 100%. Still running hours of 8 hours, yeah, that's fine. And then we have an estimated capex of 265,000. And I mentioned to you that we're gonna end with 150. I'm gonna show you why. But even though for marine batteries, marine cells, I'd say the price is close to 500 euros per kilowatt hour. But we've actually seen land cells or not very high demanding cells prices increased or decreased, to well below 100 euros per kilowatt hour. So right now I'm gonna halve these, and you see that has a great impact on the price. And one other thing that we also keep in account in this particular scenario is included in the capex cost, which I'll show you later. But this already dramatically lowers your equipment pricing. So we have some drawings, and here you can see some technical drawings, and we're going to add also on those later with single line diagrams, etc. So you can have a look at, okay, so how does it work actually? You can maybe show it to your chief engineer, see if they agree or not, especially on the electrical part, of course, but that's something we're going to improve on later. Some emissions saved, also here with the emission factors that you can change according to your specific engine. But here you see, well, in terms of emissions saved, most of it is CO2, of course. In this case, 36%, roughly 195 kilos per full day, not per 8 hours of sitting there and sleeping without any engines on and noise and emissions, yay. And also NOxes, that's also a minor reduction. The rest, of course, because typically the amount of energy here is a lot less as opposed to when sailing, is a lot less. And then finally the results, and have a look at them by yourselves, especially to see if the amount of fuel consumed per day conventionally corresponds to what we have here. It's very important to have at least the conventional base case correct, because everything else then probably also will be close to reality in terms of inputs. Of course, in terms of outputs and everything, well, there will always be deviations from reality, but then at least you have a very good estimate, of what's happening. And you see that we slice the day rate in half here, roughly, because of mostly, let's see, maintenance and a little bit of fuel, but mostly maintenance in this case. And at the OPEX part, we'll see later where that comes from. So yeah, let's go to business case, the fun part. This is what we want, of course: cost savings, slicing day rates in half, having fun with money, and reducing carbon emissions. So that's a lot of carbon emissions saved, but then again, we take into account full days of having the auxiliary engine running. You might have a different system setup, maybe you have power take on, off, etc. So there's a little tweaking to be done there. I can help you a bit with capex, but let's just first show you what we have here in terms of results. So we have about 35 tons of CO2 reduction, 12,000 liters, we're working liters because slightly smaller engines, of annual fuel savings, but most of these savings are due to the port calls. We know for a fact that these types of vessels have a lot of port calls. Most of them typically sailed a day or maybe 2 days and then spend night in port. But what if, for example, we slice the port calls in half? That's what happens, of course. The amount of port calls in this model greatly impact your business case. So that is definitely something to take into account. We're gonna stick to 180 just to have to have a good business case for ourselves. Now, because we know this is pretty fair actually, but of course it's not 180 full days in port. So okay, so we're gonna go to 120 roughly. Okay, so then I need to step up my business case game in order to still get something well beyond the 4 years return period. The battery cell price, I cannot do much about it. We've already sliced it in half. I do believe that 100 euros per kilowatt can be a fair price for these types of cell batteries, but at this point it's already lowered so much that it doesn't impact the business case too much. Of course, the fuel price will impact the business case greatly, but we're going to stick to what we have already because, well, we cannot influence that. But you can, of course, model and make some sensitivity analysis based on what you think your fuel price will do in the future. Right now, only MDO and GO is included in the premium model. You can also include other fuels there as well. So let's have a look at customizing the battery. Here we see, okay, how does engine maintenance? Oh yeah, so that's a biggie. Engine maintenance definitely greatly impacts the business case. EU ETS, only slightly, not much. No, it's only, well, it's not a lot of CO2s that we save. The battery capacity, let's see if we can, how that would work. 200, okay, not too bad. 250. Okay, so that's actually not a very big impacting factor on our business case at the moment, but I'm guessing that's because already our battery cell price is quite low. So let's have a look at the capex here. Yeah, we're only looking at equipment procurement, by the way. So if we do, oh boy, so if we do add design, engineering, refitting, commissioning, etc., in this particular case, we're going to have a pretty bad business case. That's why I'm going to leave it out. Now, it's not only why I'm going to leave it out. This is very much a estimate. Conservative, perhaps. It really depends. It varies about, well, not 10x, but 5x for different ship types, clients, people who want to do more engineering up front, or who just simply say, put it on board, we'll figure it out later. So I'm going to leave it out for now, but here, I can show you that here, you can tailor make all the different line items that we have. So for example, if you know for a fact that you have an off-the-shelf product, you can reduce that electrical engineering for the battery pack, and then that pricing is reduced as well. So you can use this to make your own estimates on design, retrofitting, commissioning, etc. as well. But we're gonna have a look at especially here the battery pack, the converter, and the transformer. So the cell price that you saw, that's only for the battery pack DC. The converter and transformer in our calculations and model are excluded. You can also maybe take them as a whole. So if a supplier gives you a battery pack, please have a look if it's only the battery pack DC, also transformer and converter, how you're gonna include it into your switchboard if you need any modifications, etc. So here we have, and that's a very big conservative estimate, 72,000 for the foundation and containment system of the battery system. We can also just simply, because right now we have about 189, well, I know for a fact that's almost cabinet size. Well, not almost, I'd say it's about a quarter of a 10 feet container. These types of capacities can be well, quite compact nowadays if you have a pretty decent off-the-shelf commercialized product. So I'm gonna reduce this to 0 and see that's, yeah, now we all are already getting close in what I said before, capex estimate of about 150. I do believe this is fair for such a ship and such a case study. So, well, again, we can maybe spend years tweaking this model. At some point we gotta say yes or no, but this gives you a very good estimate, and of course we can use this as input for budget quotes to ask from suppliers. So then finally, I do want to have a look and see where the OPEX savings is coming from, and here you see indeed maintenance is one of the biggies. And if we, yeah, this maintenance, the amount of engine hours that you save while running, that's one of the biggest components in this particular scenario. Spares and consumables, we're quite conservative in the sense that we have heard signals that that can be a lot more, but of course you can also change that around, and you see that, okay, only a few euros spares and consumables. So if you use a little bit more oil, yeah, then also there you're gonna greatly save on your costs. Fuel pricing and EU ETS, well, can't really change it or influence, so let's not care about that one. Okay, so that's our business case. I'm thinking this is pretty good. Oh, there's one more thing that we could do to improve the business case, and I mentioned leasing. So what happens if we, instead of buying everything in bulk, purchasing it, installing it on board, do a lease and maybe a rental where we put the battery pack simply on deck, hook it up with the switchboard, hopefully if that works, and then only pay per day. Boom, no cash out, almost, well, in the beginning not a lot of savings, but we do see a lot of upside in terms of not having a great risk. We still have benefits from improved CII, potentially not much, but could be EXI, Fuel EU, etc. So this could definitely be a very good thing to do for our General Prius. And of course, a lease interest rate of 5% is really low, so I'm going to change that in the future. But let's say if it's 10%, okay, then we still have some cash out. But then again, 10% lease rate, maybe if we do a period of 4 years, 5, 6 years here. So if we take a battery pack for 6 years, or we can also take this pricing or this battery pack size and maybe ask for a rental, like at one of our preferred partners, Cone. Maybe they can give you a very good pricing for a few weeks. You can try it out and then see if you can convert that into a lease or something else. But that would definitely be something I would personally do, actually do, not even recommend, but do when looking at these kinds of systems. And then maybe even reduce the lease period, because the technological development is quite amazing on these things. But then again, it all depends on your case, the amount of port of calls. The more you use it, the easier it is for you to purchase it. But have a look definitely at the leasing and the equipment, because man, that really seems interesting. And then one last thing I mentioned, a feature that we're working on for the premium members, we're making a save case so that you can actually take everything that you have and then press save case in order to export it into a nice PDF for you to show off to friends. Right now, the niceness and sexiness level of the PDF is debatable. We're still working on making it better, but we still wanted to show it to you in order for you to also provide us with feedback. What do you want in there? What do you don't want in there? Etc. We can do a lot. We can customize this PDF for you in a great deal, but right now it's simply there to have you, to provide you with at least something. So this is our base case for the this is our business case for the General Prius. And for those of you who got excited, feel free to sign up and make use of the premium features, downloadable content, etc. And also get in touch with us for more support. We've seen now that the amount of variation for the General Prius is quite substantial. A 10x deviation all in all is not very weird, but that's also because there are so many things you have to think about, so many variables in the business case that we can change. But if we look at this particular case, I would say amount of port calls, the price of the equipment system, and of course some assumptions on your operational engine characteristics. Those three are most important to take into account. Use the freemium tools wherever possible, and if you want more or need more, sign up for all the tools and the support that you will need. Thank you for watching this video and have a great day.